Hello guys, and for this part we will talk about the classical decomposition, and also for the other part about the time series decomposition. So basically we were gonna just talk about that one based on the historicals of all the kinds of time series decomposition. So with the most earliest uses and originated, that will be the classical methods. That had been generated from the 1920 and spread into the 1950 without any alternative. However, after that, the people later developed for the X11 in the 1961, 65, and then the Arima, the new another like HDL for the later, and the CIS for the 1990. So even right now, we have the X12 or the X13 for the RMRs generated in the recent year. But basically, that should be some of the advanced method that should be out the scope of this book. And we will go through some kinds of like classical methods. And another one would be the X11 in the 6.4 section, and the CIS in the 6.5 something. So that should be all the main point about this one. And the classical methods, we have two different ways for the additive and the multiplicative decomposition. We have to base on the order number. That should be the even number or the odd number. And for the additive and multiplication decomposition, we have the different ways of measure for the trend series, and also for later for the remainder. So you have to follow them step by step. Basically, we use the R function for the decompose with the data, with the time series, and then you go with the different types of, this would be the additive or the multiplicative for the methods for decomposition. But however, we basically we can extract for the component for the data, for the seasonal component, for the trend cycle component, for the remainder component, and of course for the seasonal adjusted time series component. The thing will be like they can easily just conduct by using for all the function on our studio, and that will be the point. That will be the point for the for this session first. So we were gonna just try it with some kinds of function. I would just say like this should be the practice 6.3, right? For the classical time series decomposition, right? The classical decomposition. And first of all, we gonna just try it with the Beer 2, okay, the Beer 2 data. I already just extracted and all the data from 1992 quarter 1 into the 2010 quarter 2, and we will gonna just apply it for the multiplicative classical decomposition, okay, and we will do it like decompose. The function will be decomposed, right? And if you not really understand what it decompose, you can easily use it with the decompose, and you want to gonna check it. So over here we have the data, the time series, the type we have to clarify, and filter none or not. That's quite a symbol. So this is the term and the formula for the additive model, while the multiplicative model will have this form. And just clarify about that one, alright? So okay, so now let's just do it with the decompose and the time series here. Of course, this will be the Beer 2, alright? And type, okay, we equal to, and I want to use this like multiplicative, okay? And this will be how the people create for the different one. And if you really extend it for the result, so from here we see this will be the time series, the original time series, right? And this is the seasonal part. This is the seasonal part. This could be the trend part, the trend cycle part, and last one, this would be the random or the remainder part. All of them have been generated and separated into 3 different ones. Okay, and this will be how we do it on the number. But if you really want to add in, right, just I would just do it like with the B2, right, and I want to use it for decompose, and with this one highlight, okay, and I finally apply it for the auto plot function. Let's run. Okay, you see it over here, right? Decomposition for the multiplicated time series, and this is the original data. We see it like the kaleidowal trend, and it has been separated into the trend, right? The trend over here, and this is seasonalities. You see how they fluctuate over time, and they repeat for the same pattern again and again for each year. And this is the remainder, very short. So if you multiply for it either the trend, the seasonal, and the remainder, that should be generated into the time series of the data originally. Okay, I can apply the same philosophy for the additive classical decomposition. Okay, so I use for the bit 2, and over here I want to use it for the decompose function. Type of it will equal to additive. Okay, and I have the function here, and you can see it with the same philosophy. The people do it with the same one original data. They've been separated into the seasonal, the trend data, and also for the random data. And that should be the point how you gotta just do it with the decomposition with the right over here. I apply it for the auto plot. Okay, and you can easily find the additive time series with the different kinds of, like, because it's over here, the people would do it with the slot with the different units, so they put it in the same one, so you can easily understand about that one. And you can see they can also separate it, right? You can also separate it, but basically I would say like this: if in case like when your time series they have the variation and they change over time, they have the problem about heterodicity. That means the variation, they're not stable, but the attitude can change and varies associated with the time. That means the further level, the larger for the variation, it could be something like that. So it would be better to use for the multiplicated. When if that's stable, this is better to use for the additive. So that's the reason why here, right? I prefer to use the multiplicated decomposition. Okay, and let's check and go on and just do it for the do some auto plot. So I will one more time, and over here I use for the equipment. That's another data. Okay, and if you do it for auto plot, okay, if you do it just automatically with auto plot, this will look like this, and the variation change over time with the different kinds of level. So that's the reason why we should apply it for another one, decompose, right? And I want to use for the time equal to multiplicated. Okay, and we had the separated of the component, right? But however, we apply it for another one, another layer. So I really want to just do it for the auto plot function, create for the function like this, and separate the data into the trend, into the seasonalities, and into the remainder. And of course, you are welcome to add in for the S level here to be safe. Yes, and I want to have the CG title because I have time, so I do it for classical multiplicated decomposition. of electrical equipment index. Okay, and that will be how I generate for this one section. Thank you. Okay, why the classical component decomposition can be easy to understand. It's maybe sometimes not so efficient and have some limitation about the model, and you can easily find there's all the things like there will be the problem associated with the classical decomposition. The people later developed some more advanced and complicated methods for the decomposition, and one of the sample here will be the X11. So they based on the classical decomposition, but there's some kind of add-in, and they include the extra step and the features. So that's good. When that can really, one of the most significant advantage could be they can generate for all the estimation of available for all the observation, including even for the endpoint. However, the problem is it just works for the quarterly and monthly data, and they cannot generate for the prediction and confident intervals of the forecasting, and that's the main point that the people will have to talk about. Okay. So over here, we will use the function SEAS function in the RStudio of the seasonal packet. Before we have to first install and use it. So they quite easy, and you can apply it for the data of the time series, and you just clarify about X11, blah 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 blah, and then that's going to be easily just summarize for all the model for you. However, just think about this way. Think about this way. So like we have to be very careful about the function. So if you really run it and you want to just install for your component of the X11 decomposition, you will have to clarify about the system part. So like for the working directory part, for the packet. I don't know why, but with me, I tried several times, and when I run it, I have some always the problem. So the thing you have to do will be just copy, so applicate and duplicate for this kinds of function, and you can easily install for the seasonal packet and the library of the X13 library binaries. Only on that case I can run it on my computer. Maybe that will not happen with your computer, but I don't know what happened with me. So that's the way for me to do it. So now I will apply the X11, okay, decomposition on the electric data. Okay, so how we gonna do it? So I will use the data of the electronic equipment index, and I apply for the function C's S, right, and X11 clarify. So if you do it, it will generate for the function, and it creates for all the things like belong to the component of the function. The thing will be like you will have to plot it. So after when I already run it on, okay, I will just call it like the function, then I apply it for the function. So I just do it for auto plot. Okay, and I create it for the CG title only. So X11 decomposition of electrical equipment index. Okay, and you can easily generate for the graph. All right, you can see this will be the decomposition of all the data. You see the original data, you see the trend cycle data, the seasonalities, and also the remainder. Okay, that should be the data visualization of this one. However, at the same time, I will add the different component of the time series on the same auto plot. Okay, auto plot. Alright, so how we gonna to do it? I would just recommend you guys to use for the equip elect equip, and then I apply it for the auto plot function, and the series is would be, I clarify it, equal to the data. Okay, so if I do it, this will be the original data, and I want to add in for the additional layer. So auto layer, okay, I added in for the trend cycle. I will remember about that. We have the trend cycle to just create it for the trend cycle data. Oh, anyway, like I will have to clarify about this one. I create it for the name fit. This is the function, okay, and if I do it, so fit will be available here, right? And I put in the series name will equal to the trend, right? The trend component, if I want to do it. Okay, and I add for another layer, auto layer, and the term I want is for to see the seasonal adjustment. Okay, seasonal adjustment layer of the model. I want to just extract for the seasonal adjustment data, and the season will be seasonally adjusted component. Okay, and lastly, I will add for the layer for the X level. That should be year. For the Y level, that should be new order index. Okay, and another one is sheet title. I want to add in for electrical equipment, manufacturing in the Euro area. Okay, and then we plot for the scale color manually, right? I want to just set it for color manual, and values, that should be the point. So I will clarify about that. First of all, the data I want it could be gray. All right, great. Why another one? The trend component. This should be equal to, I guess over here I would say it will be blue, right? And last one, that should be the seasonally adjusted component. Okay, that should be equal to, over here I would say it could be red, right? And remember to add in for the break. Okay, also, so break here I will have the first of all the data, second of all, yeah, C combine. Okay, data, another one that should be the trend component, and the last one would be the seasonally adjusted component, right? And this is how the data work. So over here you see this would be the original data, this would be the seasonal adjusted. The smoother and the trend component, you can still see it how that will be in the blue line, and both of the trend and the seasonal adjusted component that can demonstrate for the bit drop in the 2009. That's good. Look like the data has been much easier to understand. Okay. And if you want to go and check for the model of X11 decomposition. So how we gonna do it? We use the summarize, okay? We use the summarize function, and we use for the seasonal beer. If I want to check it for whatever beer 2, right? And X11 equal, right? Okay, there's some wrong. Seasonal X11. Any problem? Error. Summarize could not find the summarize. Yeah. Yeah, that's the reason why. Okay, so they demonstrate for all the component and also the coefficient of the model, which one would be significant. Basically they're the same with the color model, and you can also see the box lounge down for the sub-zeros and all the kinds of other criteria of the model. Okay, let's talk about that later, but you know how to summarize them all, right? And finally you can create the seasonal subseries plot of the seasonal component. Okay, so we can do it here with the fixed model we create already with the electronic equip, and then we apply it for the seasonal. Okay, if you do it for the seasonal, that should be extract only the seasonal component. And let's keep going on. So I wanted you for the CG sub series plot. Okay, and it create like this one. And yeah, if you want to add it for the Y level, that's be what we call the seasonal. It's just up to you. Okay, and you can see like how they would be. Basically they're a very small change over time in each season, so it's be fine with the data. Okay, we go through very fast for the seasonal extraction RMA time series, with the advantage and disadvantage of not working only on the quarterly monthly data. With the same with the previous one, X11, this will be an advanced model and based on the another model of the component classical decomposition. With the same idea, we can also extract the seasonal data, the trend cycle data, remainder, and the seasonal adjusted data. You can easily go and run for that on the autoplot for the seasonal SEAS equip data. Sorry, the function that's also retrieved from the seasonal packet libraries from the RStudio. So they the same we use for the X11 and also for the sys decomposition. So we use the same SEAS function in RStudio. Another one would be the STL decomposition, the seasonal and trend decomposition using loose methods are for estimated for non-linear relationship. Unlike for the previous one, with the linear relationship, this will be non-linear. So that's how to handle all the type of seasonalities. It's not just for the quarterlies and monthly data. Now it can do for all the seasonalities, and it's very robust for the outlier. But however, we have to manually clarify for some kinds of the case when we have the trading day, the calendar adjustment, and we that only can use for additive. But however, if you lock all other kind like box cost transformation, that help us to just transfer the data into the multiplicative decomposition if we really want to do it. And the R codes we use for the STL, we have to clarify about the seasonal window, about the trend cycle window, right? The thing like that. And I will show you automatically like what we're going to do it on RStudio very quick. So first of all, right, in this section, right, we're going to just do with the practice 6.5. okay, practice 6.5, and we will go and just use for the seasonal abstraction in ARIMA. Okay, ARIMA time series. Okay, so we can use for the season. Okay, season, and the data here I would use for one more time with elect equipment. All right. So basically, if you run it automatically, they will understand that you go just use it for the seasonal extraction in ARIMA time series. That's different when you clarify for the X11. All right, and I just want to use this for running into the section. So I want to go and just summarize for the model. Okay, I want to see more. And you can see it over here for all the estimation of the coefficient, the p-values, most of them are available, and all the kinds of additional information. Alright, and that's not just stop it here. Let's just do it for plotting. Okay, plotting. So how we gonna to do it? So with the elect equip, we apply for the SEAS function automatically, and then I want to just do it for the auto plot. Okay, auto plot. Okay, and I want to add it for the CC title here. That should be sys decomposition of electrical equipment index. Okay. You can see over here, even for that one, they quite the same with the previous one, got the X11, right? Because that they have been generated with the same packet, and they share quite the same characteristic, so the result could be really very close to each other. Okay, and now I will do it with the practice 6.6 about the HDL. That means the seasonal and trend decomposition using lows. Okay, and with that, if I want to do it for myself, so I will just run it for the, I will have to clarify about everything. So remember about I use it for elect equip data. Okay, then I apply for the model. That's here would be XDL function. Remember XDL function from the seasonal data, and I have clarify about the trend cycle window 13 periods. Okay, 13 periods, because I remember about the elect equipment, right? Elect equipment, right? This is the monthly data. This is the monthly data. So the equipment for the periods, I would have to put it into the trend cycle window would be like 13, and for the seasonal window, it should be periodic, right? Periodic and robust equal to true. Okay, I want to do for the robust. And with that, okay, I will just stop it here first. You can see over here the same, right? They apply it and they just decompose them into the seasonal trend reminder from the original data, and this will be how the people do it on that point. And I apply it like, okay, here I want to apply for the auto plot. I wanted to see how all the kind of different function had been created from the original data, the trend, the seasonal, and the remainder. With quite pretty the same, right? Pretty the same. I would have the time for that, so I want to do it for the component. First of all, I want to see the seasonal, okay, the seasonal, and I do it for the seasonal data, and I want to clarify for the same. I want to see like how it would look like, okay. The trend, if I want to just retrieve them all, reminder, and also finally for the seasonal adjusted data is available here. Okay, however, we can also use for the MSTL, that's been automatically generated function to automated STL decomposition using with the default S window equal to 13 and T window choose automatically. Okay, and I use for the equip data and apply it for the MSTL. Okay, you don't have to clarify about anything. They would just do it for you. Okay, they would just do it for you automatically with the data, the trend, the seasonal for the 12 periods, and the remainder. Alright, and lastly, I can at the same time apply for the auto plot. This could generate for this way. Alright. Okay, guys. So finally, why the decomposition could be useful for studying about the time series data and tell us about the historical change over time of the time series. It in some way can be useful for the forecasting too. And to do that, we go through some kinds of steps. First of all, we decompose the data into the seasonal component and seasonally adjust this data. Later, we do the forecasting for these two components. With the seasonal component, we use the seasonal naming method. So we assume that the data of the seasonal component change very slow, very little, or almost no change over time. Why? The seasonally adjusted component can use any non-seasonal forecasting method to do the forecasting for the next period. Finally, when we already have the forecasting for the two components, we compile and re-seasonalize for both of them by adding the two both together. With this coding, we can use the forecast function to just do it for the seasonal adjusted data. And also for the STLF function, they will be automatically carry out all the decomposition and then forecast for seasonally adjust the series data and return it into the forecasting with the full bloat. So I demonstrate also it for very quick on the practice 6.8. So forecasting, right? With decomposition. Okay, so to do that, first of all I use the STL, the seasonal and trend with loose, right, function for the equip data, and yeah, remember about those one. I will just automatically do it with the T window. Okay, I want to clarify 13 periods and S window. Okay, I would say this could be periodic. And finally, robust. I will clarify it should be true. Okay, the data has been generated, and I call this the that should be a fit model. Okay, so this is an objective, the object of the STL function. Now let's use the navy forecast for the seasonally adjusted component. Okay, so we can use it for the object of the model. Alright, then we use for the seasonal adjusted. I just want to retrieve for the seasonal adjusted data, and then I use the naive, if you remember the naive forecasting. Okay, oh yeah, the noise forecasting for the next season. Alright, seasonal adjusted, and then I do it and I apply it, and you can see how it could be. Auto plot. Okay, and I want to use for the Y level, change it into the new order index. Okay, and that should be it. Or if you want to add for the CG title, and I will say name forecast of seasonally adjusted data. Okay, so this will be how it's gonna grab for the forecast of seasonally adjusted data and go in this way. However, at the same time, it's gonna be easier to just use the forecaster function to the STL object. So we already have the fit object, right? We have it over here already, and we just need to apply it with the fit model. Okay, and I use for the forecast, and I clarify about the methods. We equal to naive. Okay, that has been generated for the next period. Okay, and then I can apply for the auto plot. And okay, and I want to apply for the Y lab and new order index. Okay, they just also can generate for the forecasting, right? They automatically use for the XDL function to just demonstrate for the decomposition, and then they use the random walk. That's with the naive methods for the futures. Okay, and we can at the same time use easier to use the app, the STL app function. Okay, for the data without all the previous step. Okay, so we just with the beginning, I just do it with the equip data, and then I apply directly STL app function and that's gonna be it. And you just have to clarify about the method equal to here naive, and you clarify for all the forecasting. I'm pretty sure they will be generate quite the same with the result, right? You can say them and plot them if you really want to do it. Okay, and if you do it and you want to do it for the auto plot, generate it and you have the same result. Okay, and this should be how we use for the decomposition to different kinds of method of decomposition, and also for the how to use the decomposition component for the forecasting. And thank you so much for your attention.